Okay. So the term fluid is used for what, beta? Both liquids and gases. Select the wrong statement about the pressure is telling. So pressure is scalar quantity, that is correct. Pressure is always compressive nature, that is also correct. Pressure at a point is same in all directions, that is also true. So gauge pressure is delta P is equals H rho G. I told you it may be a positive, negative or zero depending upon the value of H. If H is positive, delta gauge pressure is positive. If H is negative, it will be negative. If it is zero, that will be your zero. Next one. Figure shows two containers P and Q. See here, beta. This is a container P and this is a container Q with the same base area, capital A, and each is filled up to the same height with the same liquid. Select the correct alternatives. Pressure at your X will be equal to pressure at your Y. Pressure at your X is greater than pressure at your Y. Pressure at your Y is greater than pressure at your X. Cannot say anything. Can anyone give me the answer for this one, beta? Pressure is independent of the shape of the container, beta. If the height is same, whatever is the pressure exerted by this liquid column, if the height is same, even for this one, the height of the liquid column is same. So pressure is equally distributed. So pressure at your point X will be equal to pressure at your point Y. Okay. Sure. Next one. The pressure of the confined air is your P. If the atmospheric pressure is right now for me capital P, then capital P is equals to your small p. There is a two conditions he has given right now for me, beta. P and as well as of your small p. That's it. Okay. So here, if I'm talking about right now, this one is closed. Here your pressure is right now for me small p. Atmospheric pressure is given as of your capital P. Okay. The pressure of the confined air is given as P. That means this air is given as of your small p in this part, and which is open to the atmosphere is represented by capital P. Now you know that pressure at your point when you are exerting the pressure on this one. So what happens? Can anyone tell me, beta? Whatever the pressure you are exerting at this position, this is your height, say for example H. Okay. So if I'm taking some point here, beta, this is your point of your A. Pressure at your point A must be equal to your hydrostatic paradox. That is nothing but pressure at this point. That is nothing but of your P. Clear, beta? Is it clear? How do you write the pressure at point A, beta? Pressure at your point A must be equal to your pressure due to the height of the liquid. That is nothing but H. That means the pressure at your point A is equal to how much, beta? This is equal to this pressure, beta. So that is nothing but equal to your small p. Pressure at your point H, because of this one, it is open to the atmosphere. So that will be equal to your capital P plus density of water into G into your H. Clear, beta? So capital P will be equal to how much, beta? Capital P is equals to your small p minus of your rho G into your H. So what can be your answer, beta? Capital P will be lesser than of your small p. B will be the answer. Clear, beta? See this question, beta. The volume of an air bubble is doubled as it rises from the bottom of the lake to its surface. The atmospheric pressure is 75 centimeter of the mercury. The ratio of the density of mercury to that of the lake is 40/3. The depth of the lake in meters will be equal to your how much? Can anyone, beta? The volume of an air bubble is doubled as it rises from the bottom. So I'm drawing the rough diagram for you. See. Here is right now a small bubble, and this is completely filled with your water. Okay. When you go to the upper end, the volume of this one will increase. Okay. That is becoming how much for me? 2V. And atmospheric pressure is your P0. The volume of an air bubble is double as it rises from the bottom of the lake to its surface. That means if the volume is here V, upper it will be a 2V. Atmospheric pressure is 75 centimeter of mercury. The ratio of the density of the mercury to that of the lake is given as of your 40/3. Okay, so this is your height of the lake component. Okay, the ratio of the what you call the density of the mercury to that of the water is 40 by 3 part relation. The depth of the lake in the meters will be equal to your how much? Done, beta? You know the pressure and volume are inversely proportional. If here the volume is V, the pressure will be equal to 2 times of P naught. If above the pressure is 2V, the volume is 2V, the pressure will become how much for me or P naught? Boyle's law, isn't it? So pressure at the lowest position, 2 P naught must be equal to P naught plus of your H rho G. 2 P naught must be equal to your P naught plus of your H rho into your G. Atmospheric pressure will be equal to how much beta? H rho into your G. And P naught is given how much for me? 75 centimeter of mercury. Done, beta? P naught is equal to how much? 75 centimeter of the mercury. That is nothing but atmospheric pressure. Okay, that means density of your mercury into your acceleration due to gravity into this one is 75 centimeter. That means 75 divided by your 100 must be equal to density of your water into G into your some height H. So this G and this G will get cancelled. So density of your mercury divided by density of your water will be equal to your 100 into your H divided by 75. Okay. Density of your mercury to that of water is given in the problem as 40 by 3. So this one is 40 divided by 3 into 75 divided by 100 is equals to H. I can calculate the value of H from this one. Isn't it? So this one and this one is gone right now for me. So H is equals to how much I'm getting? 10. H is equals to 10 meters. Yeah. One more question better based on this one. This one, Pascal's law. In an hydraulic jack as shown in the figure, mass of the car is W is equals to your 800 kg. A1 is given as 10 centimeters square. A2 is given as 10 meters square. The minimum force required to lift the car will be equal to your how much? Can anyone do it better? Whatever the pressure you are applying at your A1, the same pressure will be applied at your A2. That means F1 divided by your A1 must be equal to your F2 divided by your A2. Pascal's law. Okay, so F1 is equals to how much for me? F. Area of this one is equals to 10. That is equals to F2 is nothing but weight. That is nothing but equal to your 800 kg. That is nothing but M into G. So it will be equal to your 8000 divided by 10 into 10 to the power of your, how much is this one beta? 4. A2. 10 meters square and centimeters I'm writing. That is centimeters square. Clear beta? Okay. So this 10 will get cancelled. So this will be 10 power 3 and this will get cancelled. So F will be equal to your how much beta? F is equals to your 8 by 10. That will be equal to your 0.8 Newton. B option will be the answer. Done beta? Sure. Very good. Very important topic beta. Bioenforce. Bioenforce. Are also called as buoyancy. I hope you might have been seeing this situation so many times in your life. Like when I take a football and immerse in the water and leave it, what happens? It will try to move in the upward direction because liquid is exerting some force in the upward direction. The force exerted by this liquid in the upward direction is called as a what? Buoyant force, beta. And buoyant force is always acting in the upward direction. Buoyant force always acts in which direction, beta? Upward direction. So I can say here, when a solid partially, very important, try to listen it very carefully, beta. We get regularly questions based on this one. So when a solid is partially or completely, I can say, or completely immersed in a liquid, due to pressure difference, due to your pressure difference at top and bottom, at your top and bottom of solid, it will experience net upward force called Bioenforce force. Called what, beta? Bioenforce force, and phenomena is called buoyancy. Okay, buoyant force or buoyancy. When a solid is partially or completely immersed in liquid, beta, due to the pressure difference at the top and bottom of the solid, it will experience a net upward force. That net upward force is called as buoyant force, and the phenomenon is called as of what? Buoyancy. Is called as of your buoyancy. Is this definition clear for everyone? Beta? Any doubt in this one to anyone? Sure. So you can write here. Due to this, the weight of solid in liquid, what happens, beta? Increases or decreases? Can anyone tell me? Due to this, the weight of this solid in the liquid, which is called as of your apparent weight, which is called as of your what? Apparent weight will be less than the true weight. Will be lesser than your true weight. That is weight in air. It is weight in your air. Hence, the loss of weight. Hence, I can say that the loss of weight is called weight of liquid displaced. Try to understand this terminology better. Or is also called as of your buoyant force. Also called as of what? Buoyant force. Try to understand the terminology. So the weight of your solid in your liquid, which is called as of what, beta? Apparent weight, will be lesser than your true weight. True weight is nothing but what? Weight in the air. Hence, the loss of weight. Hence what? The loss of your weight is called what for me? Weight of your liquid displaced. So weight of your liquid displaced is equal to what, beta? Loss of your weight, or which is also called as of your buoyant force. Is it clear for everyone? So what do you mean by buoyancy, beta? When a solid is partially or completely immersed in the liquid, due to your pressure difference, at the top and as well as of your bottom of your solid, it will experience a net upward force, which is called as buoyant force, and the phenomenon is called as of your buoyancy. Is it clear?
Sir, where is the liquid displaced, sir?
Like say in your part, if this is your container and this is your body, and if you are dropping some body in this one, like say if this is body has been dropped, so what happened to the liquid? Liquid will be displaced on this side like this. It will slightly rise in the upward direction, better.
Yes, sir.
That displaced liquid is called as of only loss in weight. Okay?
Okay, sir.
Sure. Next heading and important. How to calculate the buoyancy beta? Calculation of buoyant force. Calculation of your what? Buoyant force. We're talking about your calculation of your buoyant force. That is FB. How do you calculate the buoyant force? First case is number A. When solid is completely immersed. This is the case. Try to understand the case. When solid is completely immersed, that means this is your container and it is been filled with your water. It is been filled with your water. Okay, and if your body is completely immersed in this one, somewhere here, this body is totally immersed in this one. Okay, now density of your liquid, I am representing it by your rho L. Density of solid, I am representing it by your rho S. There is one force which is acting from upward direction beta, that is your F1. From the lower side, the liquid is exerting one more force, that is nothing but equal to your F2. Okay, and height of this liquid column will be equal to, from upper part, from here to here, this height is equals to your H1. From here to here, the lower part of the height is nothing but H2. So obviously the height of the container, whatever you are taking, this is your height of your body which is completely immersed, that is nothing but equal to your H. Clear? Now tell me, what will be the force on the top surface? Force on top, that is nothing but equal to your how much? F1. So this F1 will be equal to, open to the atmospheric pressure, P0 plus the height of the liquid, that is nothing but of your H1, density of liquid into your G. In which direction beta? Downward direction. Arrow mark is in the downward direction. Now force on bottom beta. Force on your bottom, that will be equal to your F2. That is also equal to your atmospheric pressure P0 plus height of that liquid is H2, density of liquid into G. This is acting in which direction beta? Upward direction, isn't it? As H2 is greater than of your H1. So I can say that F2 will be greater than of your F1. So therefore, I can say that upward thrust or your buoyant force will be equal to how much beta? F buoyant force will be equal to your F2 minus F1. In which direction? Upward direction. Buoyant force always acts in the upward direction, but F2 minus of your F1. Now calculate this value of your buoyant force beta. FB will be equal to, F2 value will be equal to F2 minus of your F1. So if I'm doing the subtraction beta, P0 will get cancelled. So this will be your H2 minus of your H1 into density of liquid into your G. Isn't it? Still anything is there right now for me? Force is equals to your pressure into your area. I have written only pressure. I need to multiply with your area. This is also your area. So this will be also your area. Isn't it? So buoyant force FB will be equal to your H2 minus H1. From the figure you see beta, H2 minus H1 will give me the height of that body H, density of liquid G into your area of cross section. Now see this one, FB is equals to, this is volume is equals to your area into your height into density of liquid into G. Area into height will give me what? Volume. So buoyant force will be equal to volume into density of liquid into G. So this is your buoyant force formula. For all the cases, we need to use the formula FB is equals to V into density of your liquid into your G. So calculation of your buoyant force beta, force on your top and force on your bottom, because pressure is equals to force by your area. So force will be equal to pressure into area. So I need to multiply with the area to get the force. Clear? So Buoyant force, how do you calculate beta? Buoyant force is equal to V into density of liquid into your G. Okay, so rho L is your density of your liquid. Density of your liquid. Rho S is equals to your density of your solid. And capital A is your area of your cross section. And G already you know acceleration due to gravity. Clear beta? So whenever a solid is completely immersed, so how do you calculate the Buoyant force? Buoyant force will be equal to volume into density of liquid into your G. Is that formula clear for everyone? Is this formula clear for everyone?
Yes, sir.
Any doubt? See in this one, whenever a body is completely immersed, so the derivation what we have done is not no use for your NEET examination beta. The only thing which you need to remember for the NEET examination is F Buoyant FB is equals to V into density of liquid into G. This is only the relation which you will be using in your NEET examination to solve the numericals. Okay, so that is the first case when a solid is completely immersed in the water. Second case I am taking right now, number B. You try to do this one. When solid is partially immersed, when a solid is partially immersed, what do you mean by that one beta? What do you mean by that one? That means when some part is in the water and the remaining part is in the liquid. Like say this is your container, okay, and here is a block, something like this, and it is immersed in the water. So water is being taken, say for example, up to this height. Up to this height. Okay. Some part is in the water. How much part I'm taking beta? Like say from here to here, this part is X in the water. This is the area of cross section. From here, there is a force acting. So F1 will be equal to atmospheric pressure into your area. And from the lower part also, there is a force beta. That is nothing but of your F2. That value of your F2 will be equal to how much? But I'm writing here F2. F2 will be equal to atmospheric pressure. This part is there right now. That is equals to P naught plus of your X density of liquid into your G, into your area of cross section here. Isn't it? So I can write here thrust or upward force, I can say. Thrust or Buoyant force. Thrust or your Buoyant force. See from figure what I can write. Buoyant force will be equal to P naught plus X part which is immersed in the water, that will be exerting the pressure in the downward direction. So it is X density of your liquid into G into area A minus this is your P naught into your A. This total force is acting in this direction beta? Upward direction. This is your Buoyant force. Okay. Now if I multiply this one, F Buoyant force will be equal to your P naught into your A plus X into A into density of liquid into G minus of your P naught into your A. This one and this one will get cancelled. So Buoyant force will be equal to your X into your A into your density of liquid into G. Now if you see this carefully beta here, X into your A is nothing but volume of the body which is immersed in the water. So only this much part is immersed in the water. So I can write here, this one is your Buoyant force will be equal to your F Buoyant force will be equal to your volume immersed into density of liquid into G. So this is your standard formula to be remembered again. So whatever the part of the volume immersed in the liquid, that should only be taken into consideration. Clear beta? So whenever some part is immersed in the water, Buoyant force must be equal to volume immersed you need to take density of liquid into G. Like previous case also. In this one, if I'm taking what is the volume which is immersed means total volume now. So in the place of volume inverse, I'm taking V density of liquid into G. This formula is applicable for any case, beta. I'm writing here, you see, keep it a star mark and write. Bioenforce is equals to your volume immersed is equals to your volume immersed into your density of your liquid into your G. So this is your Bioenforce, applicable for any problem of your Bioenforce. So this is applied in any case. That means always upwards. Bioenforce is in which direction, beta? Always upwards. Always upwards. Or I can say opposite to weight. Opposite to weight. Bioenforce always acts opposite to the weight of the body. See it once again, beta. Whenever a solid is partially immersed, how do you calculate the Bioenforce? Bioenforce will be equal to volume immersed into density of liquid into your G. Is this clear? Any doubt in this one, beta? Is this clear, beta?
Yes, sir.
Sure. Number C. Weight of solid in a liquid. Weight of a solid in a liquid. In the bracket, apparent weight. In the bracket, apparent weight. So weight of your solid in a liquid. Or we can say your apparent weight, something like this. Like say, this is your container. Try to listen it very carefully, very important, and we'll be getting regularly the models based upon this one, this condition. There is a body which is being immersed in this one. This is your body, say for example. Okay, mass of this body is M, density of this body is represented by rho S, and this string is being fixed here, right? And it is being filled with your water up to certain height. Like say for example, this is the height up to which the water is being filled. Like this. Okay, when a solid is in a liquid, so what will be its apparent weight? That means what is the loss in weight he is asking right now. See here we have got a block of mass M. The density of that block is rho S. It is tied with a string and it is been hanging from the ceiling. Now tell me what are the forces which have been acting on this body. One is the weight of the body which has been acting on this body. Weight will be equal to mass of the body into your G. Mass is equals to volume into density of solid into G. Is this point clear for everyone? Density of the liquid is rho L. Okay. Now there is
Sir,
a
1
tension.
second, please.
Yes, beta. Weight of the body acts in the downward direction, beta, always. Weight is equals to mass into acceleration due to gravity. Mass will be equal to volume into density of the solid into your G. Clear? Tension
Yes,
in
sir.
the string will be equal to T, and this one is also your capital T. Okay, tensional force is in the upward direction. Apart from the tensional force, there is also one more force which has been acting due to the liquid. One force is acting in the upward direction, beta. That force is your Bioenforce. Is the free body diagram clear for everyone? Any doubt in this one to anyone? Please check it and tell me. Weight of the solid in a liquid I am talking about. What is the weight of the solid in the liquid? Which we call it as of your apparent weight. Okay. So when the body is in equilibrium, the first thing is the weight of the body acts in the downward direction, tension T in the upward direction, Bioenforce also in the upward direction. So what is W right now here, beta? W is weight of the solid in your air. W is weight of the solid in your air. Let me try to take another one. W is equals to your weight of solid in your air, and FB will be equal to your Bioenforce. Okay, and say W dash, that is nothing but capital T, that I am representing as of your apparent weight. Is the terminology clear for everyone? W is weight of solid in air, FB is your buoyant force, and W dash is nothing but capital T, that is your apparent weight. Now for equilibrium, what do you mean by equilibrium, beta? Net forces acting on the system must be equal to 0. Then only the body is said to be in equilibrium. So what are the forces which are been acting on the body, beta? Capital T in the upward direction, buoyant force in the upward direction, minus weight of the body in the downward direction must be equal to 0. Or I can say here P plus of your buoyant force will be equal to your weight W. So what will be the tension, beta? This tension is only your apparent weight. That will be equal to your weight W minus of your buoyant force. Okay, this T I am representing it by your W dash. So W dash will be equal to your W is how much, beta? We got V into density of solid into G minus buoyant force is V into density of liquid into G. Got an idea? Clear, beta? So apparent weight is equals to how much I can write right now? W dash will be equal to, I'm writing here, you see, W dash is equals to V into G, I can take common, beta, isn't it? Vg is your common into density of solid minus density of liquid. Clear, beta? Is it clear? If I take density of the solid outside, that means what I can do? I can divide and multiply by your rho s. Like say here I'm dividing by density of solid, and here also I'm dividing by density of solid, isn't it? So if I'm dividing and multiplying by your density of your solid, so what I can get here right now, beta? See, I'll write here like this, you get a clarity. I can write this one as W dash is equals to V into G into density of solid minus density of liquid into density of solid minus density of your solid. I'm dividing and multiplying by your rho s. So it doesn't make any difference to the equation. So I can write this one as of your W dash will be equal to your rho s will be your common V into density of solid into G into 1 minus density of liquid divided by density of solid, isn't it? So this will be equal to W dash apparent weight is equals to V sigma V density of solid into G is nothing but what, beta? Actual weight W into 1 minus density of liquid divided by density of solid. So this is your apparent weight formula. Whenever a body is immersed in the liquid, the weight of the solid in the liquid or apparent weight is calculated by the formula. Okay. W dash is equals to V into G, density of solid minus density of liquid. What I'm doing is I'm multiplying and dividing by density of solid. So here density of solid into ds. So that will become for me your ds square divided by ds. So ds will become for me common. Here it is your density of your liquid. This one is your density of liquid divided by density of solid. V into density of solid into G is nothing but actual weight, beta. That is your got right now. So apparent weight will be equal to your what, W into 1 minus density of liquid into density of solid. So I can say that as temperature increases, buoyant force will decrease. Okay, so apparent weight will increase. Very important, beta. Very important. So whenever you are increasing the temperature in this situation, the buoyant force will be decreasing. If the buoyant force is decreasing, the apparent weight of the body will be increasing. And I already told you that. What do you mean by relative density, beta? Relative density is equals to density of your substance divided by density of liquid. Now here density of liquid divided by density of a substance or solid can be written as 1 by relative density, beta. Can I write like that? Isn't it? 1 by relative density will be equal to density of liquid divided by density of solid. So this value can be written as of your 1 by relative density. So I can write here apparent weight W dash will be equal to your W into your 1 minus 1 by relative density. So this is also one of the standard formulas to do the numericals in terms of relative density. Clear, beta? Okay. So you can still simplify this one. W dash divided by W is equals to your 1 minus 1 by relative density. Or else I can write from this one, 1 by relative density is equals to 1 minus apparent weight W dash divided by W. Okay, therefore relative density is equals to your W divided by W minus of W dash. There is actual weight in the air minus of your weight in your liquid, isn't it? So that means I can say here right now, relative density is equals to your weight of your solid in air, weight of solid in your air divided by W minus W dash is nothing but what, beta? Loss of your weight in liquid. This is also one more form of your relative density. Please try to go through it, beta. If there is any doubt in this one, please let me know. Just go through it. Clear, beta? Apparent weight formula is what, beta? Apparent weight is equals to capital W is your actual weight into 1 minus density of liquid divided by density of solid. Density of liquid by density of solid is what? Relative density. So W dash is equals to W into 1 minus relative density. So W dash by W, I'm taking it out, this one down. So it is 1 minus relative density. So 1 by relative density is 1 minus W dash by W. Taking the LCM, so relative density is W by W minus W dash. That means relative density is equals to your weight of solid in air divided by loss of weight in your liquid. Clear, beta?
Yes, sir. Clear, sir.
Okay. See this one, as W minus W dash. What is this one, beta? This is nothing but what? Bioenforce only. Na? Bioenforce is nothing but what? Weight of liquid displaced. Starting, I told you, weight of your liquid displaced only is called as of your Bioenforce. This W minus W dash is also called as of what otherwise? Loss of your weight. One more term. Clear, beta? So take one small note on this one, beta. Very important for your competitive exams. See, if W1 is equals to weight of solid in air, okay, density of solid rho s. W2 is equals to your weight of solid in water. Density of water is represented by rho W. And W3 is equals to your weight of your solid in your liquid. So this is your density of liquid. So therefore I can write here relative density of your solid in water. How much, beta? So that will be equal to your density of solid divided by density of water. That means W1 divided by W1 minus W2. Ante kada? Relative density is also called as weight of solid in air divided by loss of weight in the liquid. So it is W1 minus W2. Very important formula. Relative density in your water is equals to your W1 minus of W2. W1 divided by your W1 minus of your W2. Clear for everyone? Is this clear? I'm writing this one from this one better.
Yes, sir.
Chalo. Next one. Think and tell me this one better. Relative density of solid in liquid. That means density of solid divided by density of liquid. That will be equal to weight of the solid in air, that is your W1, divided by weight of your solid in right now what beta? Liquid. In the liquid means it will be your W1 minus of your W3. Isn't it? See this one once. Because in the liquid it is your W3. That is the reason W1 minus of your W3. Clear? The same way. If I am talking about relative density of liquid, relative density of your liquid, that is density of your liquid with respect to density of your water. That means this one will become for me W1 minus of W3 divided by W1 minus W2. That is nothing but loss of weight in your liquid. Loss of your weight in your liquid divided by loss of weight in water. These three formulas are very important for competitive examinations. Relative density of your solid in the liquid is equals to W1 divided by W1 minus W3. Relative density of liquid will be equal to loss of weight in the liquid divided by your loss of weight in your water. That is W1 minus W3 divided by W1 minus W2. Is that clear, beta? Clear, beta? Relative density of solid in water, W1 divided by W1 minus W2. Relative density of solid in liquid, W1 divided by W1 minus W3. And relative density of liquid will be loss of weight in liquid divided by loss of weight in water. That is W1 minus W3 divided by W1 minus of W2. Clear? Any doubt in this one to anyone? Clear, beta? Clear, beta? Sure. Next heading, law of flotations. Law of flotation. Okay, case number 1. First one is if W, that means weight of the body, if W is greater than Bioenforce FB, okay, in the bracket W is greater than of your Bioenforce. That means density of solid is greater than density of liquid. So what happened to the solid beta? Solid sinks into the liquid. Solid sinks into the liquid. With certain acceleration, A will be equal to your G into 1 minus density of liquid divided by density of solid in the downward direction. Okay, beta? How I got this one, beta? From this relation. This one. W dash is equal to your M into your A dash. W is equal to M into G. MM gets cancelled. So A dash is nothing but equal to your G into 1 minus density of your liquid divided by density of solid. W dash you take it as of your M into your A and W as of your M into G. You get this answer right. Okay. So what is the condition? If W is greater than, if weight of the body is greater than Bioenforce or density of solid is greater than density of your liquid, then the body will sink into the liquid. Solid sinks into the liquid. So when the solid will sink into the liquid, beta, when your weight of the body is greater than of your Bioenforce. Like say up to here there is a water and here there is a body. And weight of this body which is been inserted is greater than of your Bioenforce. Bioenforce is acting in the upward direction. And acceleration of the body will be in the downward direction. Clear for everyone? Is that clear? So when the body will sink, beta, the body will sink if the density of the solid is greater than the density of your liquid. Okay. Case number 2. See here, if weight of your body is exactly equal to Bioenforce, that means density of solid is equals to density of liquid, then what happens? It floats. Just immersed, I can say otherwise. So what is the condition for just immersed or floating? Weight of your body must be equal to your Bioenforce part of relation. That means in this case, the weight of the body is just floating in the liquid. So this is your floating. It is not moving inside, no. So density of solid is equals to density of liquid. Done? Case number 3. Case number 3. If your weight of the body is, if W is lesser than of your Bioenforce weight, that means density of solid is lesser than density of liquid. That means it floats with partially immersed. With partially immersed. Clear? Something like this. These cases are very important for your examination. Like say if there is a liquid filled in this one and here is the liquid up to a certain height. Okay. Now in this one, certain body is there like this. This is volume outside, this is volume inside, VI. Okay, so here in this case, right now if I'm writing, weight of your body will be equal to, W will be equal to your Bioenforce. Isn't it? This is a condition for floating. Okay, that is a condition for floating. That means V into density of solid into G is equals to volume immersed. This is volume outside into density of liquid into G. G and G will get cancelled. So volume outside into your density of solid will be equal to volume immersed into density of liquid. That means I can write here volume immersed divided by volume outside will be equal to density of solid divided by density of liquid. So that will be equal to what? Relative density. This is very important relation beta. Relative density is also equal to what? Volume immersed divided by volume outside. This is also called as fraction of volume immersed. Fraction of volume immersed If is asking the volume of the fraction or fraction of your volume immersed, that will be equal to density of your solid divided by your density of your liquid. Is it clear for everyone? If you may ask me, sir, what happens if I'm asking you fraction of volume outside, then how do you do it out? Because some part is also outside, Gada. Therefore, I can say here fraction of volume which is outside, isn't it? That is in air, I can say. The one which is in air. So V outside divided by your total volume, that is your V. Okay. So that will be equal to your volume outside will be equal to how much better? V minus Vi divided by V. That is 1 minus volume of immersed divided by your V. So volume outside divided by V is equals to 1 minus relative density. Volume immersed divided by your V. Volume immersed divided by your V. Volume, total volume of the body. It's not volume outside. It is volume of the body. No? Total volume of the body. Weight is nothing but total volume of your body. So I can take here right now. Sorry. So this one is your volume immersed divided by total body is called as of your relative density. Is called as of your relative density. Clear, beta? Weight of the body is actual volume into density of solid into G, isn't it? So G and G gets cancelled. Total volume of the body into density of solid is equals to volume immersed into density of liquid. So volume immersed divided by total volume of the body is called as relative density. If he is asking what is the fraction of your volume which is outside, that means V naught divided by V. So V naught will be equal to how much better? V minus Vi, because the total volume of this body will be equal to your V only now. Isn't it? So V naught means what? V minus Vi. So it is V naught divided by V will be equal to your 1 minus relative density. Very important relation. Clear? Third case, if the weight of the body is lesser than Bioenforce, then the body will partially immersed. So if it is partially immersed, you may ask you the question like fraction of volume immersed, how do you calculate? Fraction of volume outside the air, how do you calculate? These are the two formulas which you need to remember. Clear, beta? Sure.
Yes, sir.
One more case, and very important. Case number 4. Here, solid floats at interface of two immiscible liquids. Immiscible liquids like water and kerosene or oil and water, something like that. Immiscible means they are not mixed. Okay. Solid is floating at an interface of two immiscible liquids. So I'll draw the diagram so we'll get a clarity. So here there is a this is the shape of the container. Okay. And in this one we are having two liquids. Up to here there is one liquid beta. And up to here there is another liquid. Okay. So density of this one is ρ1, density of this liquid is ρ2. Okay. And in this one there is a body which is immersed like this, which is floating in the two liquids. Okay, so this one is ρ1, this one is your V1, this is your ρ2, and volume of this one is V2. And make sure that density of this body, if I'm taking right now, ρ2 is greater than ρ1. ρ2 is greater than ρ1. Clear, beta? Any doubt in this diagram? You got two liquids like this. First one is ρ1, another one is ρ2. Okay. Now tell me, what are the buoyant forces which are been acting beta? The first liquid will exert one buoyant force beta in upward direction, FB1. Second liquid is also exerting the buoyant force in the upward direction beta, that is your FB2, isn't it? And rho 2 is greater than of your rho 1. Yeah, okay. So what is the total volume of this body beta? From here to here, this will be your total volume. So here again I say that total volume will be equal to your how much? Total volume is V is equals to V1 plus V2. Okay, this is my first equation. Total volume is equals to V1 plus V2. Now as the body is floating, so for floating condition, total weight of the body which has been acting in the downward direction. So weight of this total system will always act in the downward direction. So that W must be equal to buoyant force of the first liquid plus buoyant force of the second liquid. So weight will be equal to volume of the body, density of solid into G. That is equals to V1 into rho 1 into G plus buoyant force due to second liquid will be equal to V2 rho 2 into G. Everywhere G will get cancelled. So V into density of solid will be equal to V1 rho 1 plus of your V2 into your rho 2. This is my second equation. This is my equation number 2. Very important relations. Clear, beta? So if I'm simplifying this relation, beta, from 192, if I'm writing this one carefully, see how do I write the equation. Taking the help of the first equation, I can write V into density of solid will be equal to V1 into your rho 1 plus V2. Can I write in terms of V1 beta? So it is V minus of V1 into your rho 2. Isn't it? So from this one, I'm writing V2 will be equal to V minus of V1. That value I'm substituting there. So V into density of solid will be equal to V1 into rho 1 plus this one is V into your rho 2 minus V1 into your rho 2. So all the volumes, if I'm taking V value, if I'm taking common beta, so this value I'm taking common. So it is V into your density of solid minus of rho 2 is equals to V1 common. This one is rho 1 minus of your rho 2. Okay, so volume V1 if I'm asking, so V1 will be equal to density of solid minus of density of second liquid into total volume divided by your rho 1 minus of your rho 2. So this is your volume of V1. In the same way, we can calculate the volume of your V2. Done, beta? Very important application, beta. Whenever a body has been floating in the two liquids, or that means some part is in the first liquid and some part is in the second liquid. Then first thing you need to write is the total volume of the body, then write the equation of the buoyant force. Then simplify that, only the thing we get the answer for that one. Very important relation and direct shortcut formula to such type of a liquids problem. Clear? Clear, beta? So tomorrow we'll try to keep one complete class based upon this one. We'll try to do even the YouTube problems. We have not done some YouTube problems we need to do. When it is accelerating in the front direction, inclined tan theta is equal to A by G applications, that we'll try to do it in your tomorrow session of your class. Okay, beta? Ciao. Take care. Bye.
Thank you, sir.
Bye, beta.